This is the Math 7 Solving Equations Review, so it's the second half of Chapter 3. This is going to be solving one-step and two-step equations. So let's go ahead and get started. Our first section that we went over was solving equations with addition and subtraction. So what we really have to remember are those couple steps that we wrote down in our notebooks. We need to draw a railroad track so we can separate the left and the right side of our equation. We use the inverse operation or the opposite operation to solve or isolate, our variable. Then we'll solve it by actually doing the math. And then most of the time we'll be asked to do a check step. So here it just says solve, and I'm going to show you a couple check steps in here since we didn't have a lot of time in class. So our first problem here says solve c minus 7.6 equals -4. So I'm going to go ahead and draw those railroad tracks. Here, since there is subtraction happening, we're going to use the addition to undo that operation. So we're going to add 7.6 to both sides. Those 7.6 on the left cancel out, and we're left with just c equals, and we have a -4 plus a positive 7.6. So here we know we have more positives than we do negatives, so we take 7.6 and we're going to subtract, and we end up getting 3.6. So your answer should be 3.6. Now the way you would check this is go back to that original problem here, and we're going to plug in what we found c to equal. So we said c needs to equal 3.6. So we're going to plug that in, 3.6, and then copy down the rest of the problem. Minus 7.6 equals -4. And then we actually have to do that left side. So 3.6 minus 7.6. That should be a -4. And since -4 does equal -4, we know we are correct there. So that's how your check step is. It's just plugging in what you found your variable to be, making sure it actually makes the equation true. So our second question here is also addition and subtraction, but we're dealing with fractions, which is always good practice. So we have 1/2 equals q plus 2/3. Since addition is happening in the original problem, we're going to use subtraction. So we're going to subtract 2/3 from both sides. We're left with just q, and bring down your equal sign. So we're doing 1/2 minus 2/3. So here, when we are subtracting fractions, we need to make sure that we have a common denominator. So to make our common denominator, we need them to be 6's. So this should be 4/6 and 3/6. So then 3/6 minus 4/6. I'm going to look at my numerator, 3 minus 4. I get -1. Denominator stays the same. So it's -1/6 equals q. And that's our answer there. Again, we have some addition subtraction, but here we're actually given a word problem, and we need to first translate, then solve. So it says the difference between a number b and 7.4 is -6.8. So difference is subtraction. So b minus 7.4 is means equals that -6.8. And now we're going to solve. So this is originally subtraction. We're going to use addition. So we're going to add 7.4 to both sides. Those 7.4s cancel out. B equals, again, we're adding numbers that have different signs. We have a -6.8, a positive 7.4. So again, we have more positives than negatives, so we know our answer is going to be negative. And we're going to take the larger number, 7.4, subtract the smaller, and we should end up with 0.6 as our final answer. So B equals 6/10. Here we have 5 2/4 more than a number A is 7.5. So more than there is going to be addition. So we have 5 2/5 plus A equals 7 1/2. So here there's addition happening, so we're going to subtract 5 2/5 from both sides. 5 2/5 on the left side cancel out. We're left with A equals. Now here, again, we're going to need that common denominator. So 1/2 is going to turn into, we're going to multiply by 5, and get 5/10. Here, we're going to multiply by 2 and get 4/10. Since we can do 5/10 minus 4/10, we don't need to change these into improper fractions. If we weren't able to do this and it would be negative, we'd have to borrow, but we don't have to worry about that yet. So 5/10 minus 4/10 would be 1/10. And then 7 minus 5 is 2. So your answer is 2 1/10. So those were one step with addition, subtraction. We're going to dive right into multiplication and division. So here we have our coefficient of negative 1.5 and then our variable n. Since they are next to each other, that is multiplication. So we're going to divide both sides by that coefficient. And it is a negative number, so we're dividing by negative 1.5. So those negative 1.5s cancel out, and we're left with a positive n. So 3 divided by negative 1.5. So I know since it's a positive divided by a negative, it is a negative. So I'm going to write my negative sign there. And then 3 divided by 1.5. 1.5 goes on the outside, 3 on the inside. We need to make this divisor, this outside number, a whole number. So we're going to move that decimal place once to the right. I do the same thing on the inside. 15 goes into 30 2 times, and we are finished with that. So it should be negative 2 equals n. Be careful with those positive and negative signs. Make sure you're checking over that. Our next one says 26 equals negative 8/5 y. And this is one of our special cases. We want to get rid of that coefficient. We want our variable to be alone. So the only way to get rid of that, since this is next to each other, negative 8/5 divided by negative 8/5. So when I am dividing fractions, I end up doing our keep, change, flip. So it's negative 8/5 multiplied by negative 5/8. And that's how I'm able to cancel things out and left with just a y. So I'm actually multiplying both sides by negative 5/8 to get my y alone. So I'm going to do negative 5/8 multiplied by 26 over 1. And here it's going to be negative since I'm multiplying a positive by a negative. And I see that these two diagonals are even, so I'm actually going to divide them by 2 in order to do a little simplifying. So I'm left with a 4 and a 13. And when I multiply straight across after that, I get negative 65 over 4. And when I simplify that, make that into a mixed number, I end up getting negative 16 and 1/4. If you have negative 16.25, that also works, fraction or decimal. I just kept mine as a fraction form. Our next ones, again, we are going to have to translate these first and then go from there. So the product, that's multiplication, of 15 and a number x is negative 75. So I have 15x, or 15 multiplied by x, which is why we get rid of that x sign for multiplication. When they're next to each other, it means multiply. Is an equals negative 75. So from there, we're going to go ahead and solve. So I'm going to draw my tracks. This is multiplication, so I'm going to use division in order to get my x by itself. X equals a negative divided by a positive is a negative. And then 75 divided by 15 gives me 5. So x is equal to negative 5. The quotient of n and 1.6 is 5. Quotient means division. Oops. Quotient means division. N and 1.6 is 5. So I'm going to actually set this up in fraction form. N divided by 1.6 equals 5. If you had a division sign like n divided by 1.6, that's also all right. Just be aware that you're going to see this setup more often. So here, in order to get n by itself, we need to undo division with multiplication. So I'm going to multiply by 1.6. And I'm left with n equals 5 multiplied by 1.6 should be 8. So n equals 8. Here we have two-step problems. So what we have to do first, our steps are pretty much the same. Draw those railroad tracks, but then we have to undo our addition or subtraction. So we are going to get rid of what's not connected to our variable first. Then we will get rid of what's connected to our variable. So here that plus 9 is not connected. So we're actually going to get rid of that by using the inverse operation. So we're going to subtract 9. And we're left with negative 4p equals negative 5 minus 9. So it's going to become more negative. So it's negative 14. Again, that is integer rules, so be very careful on that. So we're left with negative 4p equals negative 14. So here we want to get p all alone, so we need to isolate our variable. We're going to undo this multiplication with division. And we're left with p equals a negative divided by a negative is a positive. So 14 over 4, I would see how many times 4 goes into 14, which is 3. And we're left with 2 left over, 2/4. So when I simplify that, it's going to be P equals 3 1/2 is your answer. Or 3.5 would also be all right. So these are just like two one-step equations squished together. So we're undoing our addition or subtraction first, then isolating our variable. So our next problem here has 3f minus 8f equals negative 65. So here, this one looks a little bit different because we have the same variable twice on the left side. So what we can actually do for our first step is simplify that. We're actually going to combine PL, can't spell simplify, S-I-M-P-L-I-F-Y. There we go. We're going to simplify that by combining our like terms. So 3f minus 8f's, or really it's something f, so 3 minus 8 is going to be negative 5f equals negative 65. So that's actually the first step. We're simplifying, and then from there we get to isolate our variable, which here is f, so we want to divide by the coefficient, which is negative 5. So f equals, and then we have negative 65 divided by negative 5. So a negative divided by a negative is a positive, and so we're going to get a positive 13. So f equals 13. So those are all of our practice problems for our review. I suggest you look over old homework assignments as well as your notes. Re-watch any of the sections you'd like to watch on here to review, and then good luck studying.